is any collection of letters, which are called variables, numbers, or products of letters and numbers, with addition and subtraction, but there's no equal sign. Okay, so that's what makes it an expression, is that there's no equal sign. A variable is a letter used to represent an unknown number. So any number we don't know, we can put a variable in there. It can be any letter. A term is a letter, a number, or a product of a letter and number. So for an example, you could just have a 2, or you could have an x, or you could have like a 3x. These would all be considered to be terms. Okay. Factors are so if you have a term and you take the things that are being multiplied together and you take them apart, those are the factors. And the product is basically the result of multiplication, or the answer. Okay. So if you have something like 3x squared plus 4x minus 6, this whole thing is an algebraic expression.
What's that word under term next to number?
Under term, a letter, a number, or a product. It kind of ran together. Let me rewrite it for you.
That's all good.
So this whole thing is an algebraic expression down here at the bottom. These individual parts are terms. Okay, oops. This x right here, that's a variable. And then if I take like 4x, I can break that into 4 and x. Those are the factors. And then 4x is the product. Okay, so a power or an exponent, these are both the same thing, is a symbol for repeated multiplication. Okay, so it's a small number and it's raised over a base, and it tells you how many times. Okay, so if you have, we'll just say x to the fourth. This is the exponent, and it can also be called a power, like the power of 4. And what that equals is 4 times that you multiply x together. Okay, so you don't say 4 times x, you say x times x times x times x. 3 squared. That's not 3 times 2, it's 3 times 3, so it's 9. Okay, the base is the number under an exponent that gets multiplied. Okay. When you're going to write a verbal expression for an algebraic expression, there's a couple different ways to write it because there's a few words that mean the same thing. So here we have 3x and 4. I can write this as 3 times x to the fourth. Or I could say 3 times x to the power of 4. Okay, so we can call this x to the fourth, we can call this x to the power of 4. Here I can say 16 more than, that's another way to say addition, 5 times z squared. I can say 5 times z to the second plus 16. I could say 5 times z to the power of 2 that's not what I meant. To the power of 2 added to 16. You know, there's a lot of different ways to say that. So on a question like this, where you're taking a number or an expression and turning it into words, there's a lot of correct answers. Because there's a lot of ways to say these things. So, these is not a complete list by any means, but these are just some of the more common ones. So you've got some, you've got more than, obviously plus, in addition to, increased by, of course add or added, plus some, you could say raised by. Usually if they ask older, like 10 years older, you're adding 10. Okay, so those are just some of them. There's a lot more, but these are some of the more common ones. With subtraction, you have obviously minus. You have less than. Subtract or subtracted. decreased by, it's called lowered, maybe younger, right? If you said 10 years younger, you would subtract 10. Let's see, decreased by, fewer, or fewer than, things like that. Multiplication. Obviously the word times. Also the word of. Of means to multiply. We have special words for multiplication. Twice means to multiply times 2. Triple, you're going to multiply by 3. Double, you multiply by 2. Product means multiplication. Okay. Some words for division, of course, we have divided, or divided by. The word quotient relates to division. The word per, you divide, which is where the word percent comes from. Percent literally means divided by 100. Because cent is the word for 100. That's why we call pennies cents. Okay, so quotient, per, divided by. You might have half, which is to divide by 2, or a third, which would be divide by 3. A quarter, divide by 4. This example, that should just be a number. I don't know why that came. So it's a number t more than 6. So here's our keywords, more than. That means plus. So this is 6 plus t. Or you could also say t plus 6. Okay. 10 less than. Okay, so less than is a key for subtraction. Product of, I'm going to use just a dot for multiplication because we'll be using x's. So from now on, multiplication is just going to be a dot or parentheses. So we have subtraction and we have multiplication. Okay. Now, when you see 10 less than, this does not mean 10 minus. This means minus 10. So I want to put that over here. This right here, whenever you see that, it means minus 10. So if you had 5 less than, it would be minus 5. It's the only one that goes backwards. Like here I can do t plus 6, but here I have to do something minus 10. Okay. And then we have this part, product of 7 and f. So that part is 7 times f. Or you can just do 7f. So when I put these together, it's 7f minus 10. Okay. Down here I have 2/3 of. This is the word for multiplication. 2/3 is a fraction. And the volume is V, so I'm going to use the letter V. So what I have is 2/3 times V. Okay. Sorry. Dr. Martinez is going to order 250 keychains printed with his athletic team's logo and 500 pencils printed with their web address. And we want to write an algebraic expression that represents the cost of the order. Okay. I'm going to use K for keychains and P for pencils. But you can use any letters you want. You can use X and Y, A and B, it doesn't matter. Just use whatever seems to make sense to you. If I'm ordering 250 keychains and I want to know how much that costs, I would multiply 250 times the number of keychains, or the cost of the keychains. And I'm ordering 500 pencils. So this would be my algebraic expression. I have 250 Ks and 500 Ps. Okay, evaluating. Okay, remember how I said you cannot solve an expression, but you can evaluate an expression. Okay, and to evaluate essentially means to simplify the expression as much as possible. There's an L in possible. And then if you're given the values of the variables, you can substitute them in. And then simplify. Okay. Order of operations, you guys should have seen all this before. PIMDAS, or maybe please excuse my dear Aunt Sally. Either of those sound familiar? Okay. The P stands for parentheses. But it's not just parentheses. It's also brackets, braces.
Does that say substitute them and...
Them, substitute them, the values
Oh.
in, and then simplify. Okay, so parentheses, brackets, braces, fraction bars, absolute value, etc. Okay, basically it's any grouping symbol. Okay. The E is for exponents. You have M and D. Okay, so here's how the order of operation works. Okay, you start with parentheses or brackets or braces, any grouping symbol, and you do what's inside those first. Okay, and if you had, like, let's say you have parentheses inside parentheses, you do the ones on the very most inside, and then you do the ones on the outside. After you've done what's inside, or when you're inside the parentheses, the next thing you do is exponents. Exponents are like the second most important. Okay, so parentheses would be like the king, the exponents would be like the queen. Okay, Then you have multiplication and division. Now, you don't have to do all of the multiplication first and then go through and do all of the division, and that would actually give you the wrong answer. What you do is, as you move from left to right, the same way you read a paper, so as you move across this way, you do them in whatever order they come in. So as you're like reading the problem, as you're moving across the problem, if division comes first, do division first. If multiplication comes first, you do the multiplication first. What's important is that you do all of the multiplication and division before you do any addition and subtraction. So if the parentheses are the king and the exponents are the queen, multiplication and division are like the princes and princesses. Okay? And then you have addition and subtraction. Those you do last. Again, in order from left to right. So we have king, queen, princes and princesses. These would be like the lords and ladies, right? The lower people that the king and queen and the princes and princesses get to boss around. They come last on the level of importance. Or not importance, but the order you do things. Does that make sense? We've got PEMDAS, right? So the first thing that happens is anything in parentheses. So when you look at the problem, you say, okay, there's no parentheses. So I'd go to the next thing, which is exponents. So what I do is I write down the problem exactly the way it was, and I only do the part that I'm doing first. So exponents was the first step since we had no parentheses. So 2 squared, that's 2 times 2, so that's 4, and then plus 14. The next thing on my list is multiplication or division. So I come across the problem, I go minus, divide, plus. Okay, so divide comes next. So I'm going to do that division, so I get 16 minus 8 divided by 4 is 2, and then plus 14. Do you see how nothing else is changing except the thing that I'm circling? I'm doing that operation. Okay, and then addition and subtraction come in order as I see them. So I'm actually going to do the subtraction first. So 16 minus 2 is 14. Plus 14, and then I do that addition, and I get 28. Okay. On my next problem, I do have a parenthesis. So I'm going to do what's inside the parentheses first. So I have 4 divided by 2 plus 5 times, and then 10 minus 6 is 4. The next thing I'm going to do is any exponent. There are no exponents. So the next is multiplication and division, and I do those in order. So since division comes first, I'm going to do the division first. So 4 divided by 2 is 2, and then I do plus 5 times 4. That's multiplication, so I'm going to do that next. So I get 2 plus 20, and the last thing I have is addition, so I get 22. These are brackets, and I have parentheses. So basically, essentially, I have parentheses inside parentheses. So you do what's in the very inside first. So I'm going to do this parenthesis first. And everything else I write down exactly the way it already was. Okay. Now I have to work inside of the brackets. I have an exponent. Exponents come next. So I'm going to do that. And everything else I'm going to write down exactly the way it was. Now I have brackets, which are the same thing as parentheses, so I need to continue to work on what's inside of those. And what I have left is multiplication. So I'm going to do that multiplication. When you have a problem like this where you have a fraction, this fraction bar, if it has stuff to do on the top and the bottom, it acts like a parenthesis too. So what I need to do is I need to do what's on the top of the fraction and what's on the bottom of the fraction first, and then I can do this division. Okay, so if I'm looking at the numerator, I have this 2 to the third. That's the exponent, so that comes first. And I'm just going to write this down here. 2 to the third is 2 times 2 times 2. It's 8. So I have 8 minus 5. 15 plus 9. Okay. Now you can do this in 2 steps, or you can do this in 1 step. If you do it in 2 steps, you're going to take the 8 minus 5 and you'll do 3. And then you can do the 15 plus 9. And you'll get 24. Okay. Or you could do that in 1 step, and you can do 8 minus 5 is 3, and 15 plus 9 is 24 as 1 step.
You reduce it.
And then you have to reduce it. And so 3 and 24 both divide by 3. So I get 1/8. To evaluate an algebraic expression, basically if you see something like this, where it gives you an expression with variables in it, and then it says if, and then it tells you what the variables equal. Okay, so the first thing you do is you plug in all the numbers for the variables, and then the second thing you do is simplify. Okay, so I'm just going to rewrite it so I have more room, but you don't have to rewrite it every time. X is 4. So I'm going to take this 4 and I'm going to put it where that X is. Y is 5, so I'm going to take that 5 and I'm going to put it where the Y is. And Z is 3, so I'm going to take this 3 and put it where the Z is. And so I end up with 3 times 4 squared plus 2 times 5 plus, let me write that prettier, plus 3 to the third. Okay, so this was X, that was Y, that was Z. Now I'm going to use my order of operations to simplify. I need to go into the parentheses first. Three to the third is 3 times 3 times 3, so that's 27. Okay. Now I'm going to do this 2 ways. I'm going to do one where I do each step individually, and then I'll show you another one where you can do more than 1 step at a time. Okay, so this is just like method 2, and that's combining steps. So that when you look at this, you don't think to yourself, oh my gosh, it's so much to write. We can actually do more than 1 step at a time. I just want to break it down, doing 1 step at a time, and then I'll show you how to combine steps. Okay, so we're still inside the parentheses. Okay, so the next thing I do is multiplication. Okay, again, I'm still working on the parentheses because that's the first step, is doing whatever's inside the parentheses. So 10 plus 27 is 37. Now the next thing on my list is exponents. 4 squared is 16. And then multiplication, that's 48 plus 37. So that is 85. Okay, and then just in case it's kind of difficult to see what's going on, I'll just do that, if that helps. Okay, in this next step, I'm going to combine steps. I know that I need to do what's inside the parentheses and multiplication and exponents before I can do any addition or subtraction, right? So I'm going to look at this and I'm going to say, okay, that's going to be 16, that's going to be 10, and that's going to be 27. Then I can look at that and say, okay, that's going to be 48, and that's going to be 37, and then I can multiply or add. So what I'm doing is I'm doing steps kind of not in the right order, because you're supposed to do everything inside the parenthesis first and then all your exponents next. But this exponent has nothing to do with what's happening inside this parenthesis, so I can do that. These two are separate, so I can do those at the same time. So you can do kind of separate operations at the same time, just so long as I don't add 5 plus 3 and multiply it by 2 and then take it to the power of the thirds. Does that make sense? So you can do more than one step at a time, just so long as you don't do steps that contradict each other. I can never add before I multiply. Okay. Or I can't add before I take it to the power of 3. I have to do things like here, I couldn't multiply before I took the exponent. I had to take the exponent first. So it's okay to do, and you'll see this obviously is much shorter than that. So you can do that if you want. Okay. Oh, and by the way, if you haven't taken FCAT yet, these kind of things show up on FCAT. All right. So the reflexive property. Reflexive sounds like reflection, and that's basically what it means. It's all numbers are equal to themselves. Okay, in symbols, A equals A. Examples, 4 equals 4. 2 equals 2. Do we all agree with that? I'm going to pause this for just one. Okay, so for this, basically what it says, if one quantity equals the second, then the second equals the first. Okay. So basically, if A equals B, then B equals A. Examples of that. Six plus 6 is equal to 9 plus 3. So 9 plus 3 is equal to 6 plus 6. Or you might say like 5 is equal to 2 plus 3. So 2 plus 3 equals 5. That's just another example. I'm not going to list the words for transitive property. I'm not going to write out the description. It's very long and I didn't make the box big enough. Okay, but I will do the symbols. All right, so it's if A equals B and B equals C, then A equals C. So you can basically take out that middleman. So if one thing equals a second and the second equals a third, then the first equals the third. So if 2 plus 3 equals 5, and 5 is equal to 4 plus 1, then 2 plus 3 is equal to 4 plus 1. Okay, for the substitution property, any quantities that are equal can be substituted. So if you have A equals B, okay, then B can replace A. Example of that, if I have n equals 11, and then I say 4n, I can say that equals 4 times 11. So I can take the n out and put the 11 in. Represent the same quantity. So if I had like 5x plus 6x, that's the same thing as 11x. They represent the same quantity. They're worth the same thing. It would be like $1 bill is equal to 4 quarters. These would be equivalent. Okay. The additive identity is 0. It's just the number 0. And that's because you can add 0 to anything. And you get that same anything back. Okay. So oops. Let me change that. Okay, so in words, what that says is for any number A, the sum of 0 and A is A. So A plus 0 equals A. Or 0 plus A equals A. It doesn't matter what order you add it in, right? It's not going to change anything. So if I take 5 billion and I add it to 0, I get 5 billion back. That's why it's called the additive identity. It doesn't change the identity of the number you added it to. Okay, the additive inverse Okay, so additive inverses are numbers that when you put them together, you get 0. So a number and its opposite. So if you do A and you add to it the opposite of A, or negative A, you get 0. So other examples of additive inverses, I could do 3 and negative 3. I could do 10 and negative 10. Basically, any positive and negative of the same number are additive inverses. Identity, you also have a multiplicative identity. And the multiplicative identity is 1. And that's because if I multiply 1 times anything, I get that number back. Okay. And then you have the multiplicative property of 0. And that's because if basically the multiplicative property of 0 says that when you multiply anything by 0, it equals 0. Okay? So basically, A times 1 is A, or 1 times A is A. It doesn't matter what order. So 6 times 1 is 6. 40 times 1 is 40. It doesn't matter what I pick. Anything times 1 is itself. For the multiplicative property of 0, so if I multiply anything at all times 0, I get 0. And it does not matter what number I choose. If I pick infinity and I multiply that times 0, it's still 0. 10 times 0 is 0. It doesn't matter, big or small. Multiplicative inverses, those are the same thing as reciprocals. These are numbers that when you multiply them together, they have a product of 1. And you guys know reciprocals. 2 and 1/2. 2 and 1/2 are reciprocals. When I multiply them together, I get 1. If I multiply 2/3 times 3/2, these are reciprocals. They equal 1. Okay. I'm not going to do the words, but the big thing is you cannot have a 0 in the denominator. So the only number that does not have a reciprocal is 0. Okay. Okay, so if I do 5/4 and I do 4/5, these are reciprocals of each other. They're also multiplicative inverses. They give me a 1 if I multiply them. If you have a whole number, the reciprocal is 1 over that number. We're going to evaluate this and we're going to use the properties named in each step. On a test, I won't expect you to name every property just to be able to evaluate, but we're going to go ahead and go through it. First, we do what's inside the parentheses. if you're taking 4 minus 3 and you're actually doing that process, our first step was actually substitution, because we substituted 1 for 4 minus 3 because they had the same value. Okay. The next thing we're going to do is we're going to multiply by 1, because that came first. 7 times 1 is 7. And what we used in that second step was the multiplicative identity, because we multiplied by 1. Anytime you multiply by 1, you're using the multiplicative identity. The next thing we have to do is this other multiplication. And that step is multiplicative inverse. So anytime you multiply by itself, something by its own reciprocal, it's the multiplicative inverse. Now I can do 7 minus 1 and then plus 1, but what happens when I do minus 1 and plus 1? Negative 1 and a positive 1, what happens if I add those together? I get a 0, right? So if I do that first, I'm actually using the additive inverse. Now I don't have to do that. I could do 7 minus 1, which is 6, and that would be substitution again, if you had done it that way. But then 7 plus 0 is just 7, and that's the additive identity. Now again, if I had done 7 minus 1 was 6, and then 6 plus 1 was 7, I would have used substitution, substitution. Again, I'm not going to expect this though. I don't expect you to do this. I know what I was forgetting to do. Darn it. Can we get out of here in 15 minutes? All right, I'm going to have to run downstairs. I forgot to bring something up. But like I said, I don't need you to write down all the properties. I just wanted to go through them with you. I need you to be able to do this portion over here. Okay. I don't need you, I'm not going to expect you to write all those properties. I'm going to expect you to do this side. I just wanted to go through it with you. Do you have it all?
Just getting this side done.
Okay. The morning commute, right? Or in your afternoon commute? Your commute is when you go from like your house to school and then from school back to your house. You've heard that term, right? The commute? Okay. That's what the commutative property is like. Okay, now, commutative property only works for addition and multiplication. It does not work for subtraction or division. And so it's like this. If I do A plus B, that's the same thing as B plus A, right? Because 2 plus 3 is the same thing as 3 plus 2. Or A times B is the same thing as B times A, because 2 times 3 is the same thing as 3 times 2. The reason it won't work for subtraction is because 2 minus 3 is not the same thing as 3 minus 2. or 2 divided by 3 is not the same thing as 3 divided by 2. So it only works for addition and subtraction or multiplication, and so all it means is I changed the order. That's all commutative property does. It just changes the order. And sometimes it's useful because if you have a string of numbers to be added and subtracted and everything together, sometimes it makes more sense to change the order of them because they'll add together quicker and easier in your head. Associative property, well, associations are groups. So the grouping. Again, this is only for addition and multiplication, and it has to be all addition or all multiplication. So if I have A plus B together in a group and I add C, it's going to be the same as if I take A and I add it to B and C that are in a group. Or if I have A times B in a group and I multiply it by C, it's the same thing as if I had A and I multiply it by a group with B and C. Example of that. Here I have 3. 1 plus 2 is 3, and then I'm going to add 3 to it, and that gives me 6. Or here I have 1, and then I'm going to add it to 5, I get 6. Or if I do same thing. This gives me 2 times 3, which is 6, gives me 1 times 6, which is 6. So it doesn't matter what we group. But you'll notice that the only thing that moved is the parentheses. Everything stayed in the same order. So associative moves parentheses, commutative changes the order. Okay, a list of items that you wanted to buy for a party and how much they cost. Okay, so here's the list of items. If I want to know how much they cost, I'm just going to add them together. Right? Now, this is 75 cents and this is 25 cents. Right? So it actually makes more sense to put those two together. Because it's going to add faster, because I can go 75 and 25 is $1, so, and then 6 and 23 is 29, plus that dollar gives me 30, and then 14 plus 20.50 is 34.50, so that's 64.50. So I used the commutative property, right, to change the order of the numbers, to put numbers that I could add together more quickly in my head together. I can do the same thing here with this multiplication. Well, I can do 5 times 7, that's 35, and then I can do 4 times 2, and that's 8, and then I'm multiplying 35 times 8. Or 35 times 4 and then times 2, that's not easy to do in my head. But 5 times 2 is easy to do in my head, right? And 7 times 4 is easy to do in my head. And that's 10, and that's 28, and that's real easy, 10 times 28. So I'm changing things around and I kind of, group them. So I used commutative and associative. And that's what those are useful for. Just moving things around or grouping things differently so that you can make the multiplication or the addition quick in your head kind of a thing.